Hey, welcome back to Math with Patrick. Today is October 9th, and this is problem 282 from the Daily Epsilon calendar. And we should show why the answer is supposed to be 9 for today. So I see a limit. It's a limit as x approaches 0 of this expression, x squared times cotangent squared of x over 3. So with a limit, basically we're just trying to figure out what value does this thing approach once we get closer and closer to the number 0. And usually when you solve limits, at least for me, the first thing that I check is just direct substitution, because if we're trying to figure out what value this takes as x approaches 0, it would just kind of make sense to plug in 0. Now, some functions don't behave nicely. Like some functions, I don't know, I could graph one that looks like this, where we would be approaching, say, the value 2, whereas maybe plugging in a number would give me the value 3. So there are some kind of tricky functions out there where if you plug in this number, maybe that's not actually the value you are approaching. There are some other functions too that, kind of like before, do have a little hole right there. And so if I do try just plugging in this number, I'm going to get something undefined. Usually this happens when you're like dividing by 0 or something. I think that's going to be the case with this expression, but it's good to check. First things first, I don't like cotangent, to be honest, and so I'd rather rename it as tangent. They are just reciprocals of each other. So this problem would be the same as if I just did x squared over tangent squared of x over 3. And also, I think I could do that squaring later. So maybe I'd rather think of it as the limit as x approaches 0 of x over tangent of x over 3, and then squaring it afterwards. And I forget if this is actually going to be equal to like squaring the limit of just kind of this quotient right here. I don't actually know if this is true or not. I would like it to be true because this is an easier limit to evaluate, but I'm just going to hold off on that for a sec. I don't trust it just yet. Anyways, trying to do direct substitution here, I would get a 0 on top, and then on the bottom, tangent of 0 over 3 is just going to be 0. And then I'm kind of thinking back to the tangent graph. It kind of looks like this. And so if I plug in 0, I'm also going to get 0. So we are in this scenario where we're dividing by 0 here. This is considered an indeterminate form. When you're doing limits, basically when you just try direct substitution and you get 0 over 0 or like infinity over infinity, these scenarios, you kind of need more advanced tools. And here, I'd just like to use L'Hopital's rule, I think. I think that's the simplest way to do it. And again, I'd really like to be able to just remove this squaring from my thinking about limits, but I don't know if that's allowed. So I'm not going to do it. Instead, I will just apply L'Hopital's rule faithfully. It says that this limit that we're trying to solve here is going to be the same or equal to the same limit as x approaches 0, as long as I take the derivative of the top and bottom. It's kind of a powerful tool. It's relating the values here with their slopes, and somehow the limit is still the same. I think it's pretty cool. Anyways, the derivative of x squared is just 2x. And then the derivative of tangent squared, it's going to be pretty tricky because I know the derivative of tangent, but I guess I could use a chain rule. So we could take the derivative of kind of the outside function. I would get 2 times tangent of x over 3. That's kind of treating it as just a power rule. Then I want to multiply that by the derivative of the inside part. The inside part being tangent of x over 3. Now this is yet another chain rule, so I would need to multiply that by the derivative of the outside part, which is tangent. The derivative there is secant squared, I believe, over of x over 3. And then finally, I need to multiply it by the derivative of the inside part, which is going to give me 1/3. This is kind of what I was talking about earlier, where I really wanted the square to be not within my limit, but I couldn't really convince myself that I was able to take it out. So we're just forced to do some pretty complicated derivatives here. Okay, tangent of x over 3 times secant squared of x over 3. And then I do notice that this 2 right here and this 2 up here can cancel. And then this divide by 3 on the bottom, I could actually bring to the top. And I do have a 3 like that. Okay. And if I tried direct substitution again, I would still get a 0 right here and a 0 right there. And then secant squared of 0, that would just be 1. So at least there, I could plug it into the secant squared, but I can't do anything with this one yet. Again, just because of the indeterminate form of 0 over 0. What I am going to do, though, I think I'm allowed to split it up, kind of using maybe the product rule of limits, where I'll just put the limit of, that was secant squared of x over 3 over here. And then actually, secant squared is just reciprocally cosine squared. So we do get cosine squared of x over 3 over here. And then like I was saying, this one we can actually solve with direct substitution. Cosine squared of 0 is just 1, because cosine of 0 is 1, and then squaring the 1, we still get 1. So this factor right here just doesn't really do much in my limit, and so fortunately, I can take it out. And let's still L'Hopital's rule this guy, so we can kind of get rid of that indeterminate form. I will take the derivative of the top. That will just be 3. And then we already did the derivative of tangent of x over 3, kind of in our process of doing tangent squared of x over 3. And so that's just going to give me secant squared of x over 3, and then not forgetting that chain rule to multiply by that 1/3. Cool. And this one should be solvable with direct substitution now. Maybe let me kind of move that 1/3 into the top like this. And then we already saw that secant squared of 0, not equals, secant squared of 0 should just be the value 1. And so here I can use direct substitution, and I do get 9 for today, which is today's date. That's great. So I think we're all done. Basically, I would just apply L'Hopital's rule until the expression kind of gives us some kind of solution. And this 9 is kind of coming from the fact that we applied this kind of times 3 twice through our 2 uses of L'Hopital's rule. So I think we're all done. Thanks for watching, and I'll see you tomorrow. Bye.